UART, or Universal Asynchronous Receiver Transmitter, is one of the most basic ways to communicate between ESP32 and other devices. The ESP32 has three UART interfaces: UART0, UART1, and UART2. By default, UART0 is used for serial communication over USB and debugging. That's pins GPIO1 TX and GPIO3 RX. But you can reassign the UART pins to almost any GPIO thanks to the ESP32's flexible pin mapping. The default baud rate for UART0 is a Lambda 5200, but you can configure it from as low as 300 to over 1,000,000. Depending on your application and hardware, in code, just use serial.begin with Lambda 5200 to start communication, or use serial 1 and serial 2 for the other UARTs. With the right setup, UART is fast, lightweight, and reliable, ideal for streaming data between chips. When working on IoT projects with the ESP32, understanding the I2C protocol is a game changer. I2C, or Inter-Integrated Circuit, lets multiple devices communicate using just two wires, SDA for data and SCL for clock. On the ESP32, almost any GPIO pin can be used for I2C, thanks to its flexible pin mapping. By default, the ESP32 acts as a master device, controlling communication and initiating data transfers. But what's powerful is that it can also be configured as a slave, allowing it to receive instructions from another microcontroller. This opens the door to complex systems where multiple ESP32s or sensors work together seamlessly. Using libraries like Wire.h in Arduino IDE, it's easy to set up both modes. You can connect up to 127 devices on a single bus, just by assigning unique addresses. Whether you're building sensor networks or smart home gadgets, mastering I2C on the ESP32 gives you serious control. SPI, or Serial Peripheral Interface, is another powerful communication protocol you can use with the ESP32. Unlike I2C, which uses two wires, SPI typically uses four: MISO, MOC, SCLK, and SA. This setup allows for faster data transfer and full duplex communication, meaning data can be sent and received at the same time. On the ESP32, you get multiple SPI buses, including variable SPI and high-speed SPI, giving you flexibility to connect multiple peripherals like displays, SD cards, or sensors. And just like with I2C, the GPIO pins are software configurable, so you're not limited to fixed hardware lines. SPI works on a master-slave model. The ESP32 usually acts as the master, controlling clock and data flow. Each slave gets a unique chip select (CCS) line, which allows precise control over which device you're talking to. Compared to I2C, SPI is faster and better for high-speed data, but it does require more pins. So if speed is critical, SPI is the way to go.